Hello. This is Mr. Chan here. Welcome to Friday, October the 1st, and we are going to be doing radicals today. Okay, so a radical is another name for an operation with roots. We've seen these roots before. So we have square roots. We also have a cubed root. This one would be new. And basically, a square root is, as you know, when we have a square root, the number inside is, of course, we're looking for a number that multiplies by itself to equal the number inside. That was probably explained pretty poorly. Let's do some examples. So square root of 9 is, of course, 3, because 3 times 3 is 9. The square root of 16 is 4, because 4 times 4 is 16. Another way you can write square roots is like this: 9 to the 1 half. 1 over 2 means square root. Okay, so this is 3. 4 to the 1 half is 2. Whoops, I meant to use 16. That's okay. 16 to the 1 half is 4. Okay. So again, these are exponents. You can't really tell because my handwriting is bad, but this is what the square root does. Okay. So every time we take the square root of a number, we're looking for a number that multiplies itself to equal that number under the square root. A cube root's a little bit different. A cube root, we're looking for a number that multiplies itself 3 times in order to get that final answer. So another example of this might be the cubed root of 8 is 2, because 2 times 2 times 2 is 8. Okay. The cubed root of 125 is 5, because a 5 times 5 is 25, times 5 again is 125. We're not going to be seeing too much of this cubed root, but I did want to just introduce you to the concept. Similar to, we have the square root that can be written as an exponent. We also can write the cubed root as an exponent as well. And instead of the base to the power of a half, we're going to do it to the power of a third. A third means cubed root. A half means square root. A quarter means the fourth root. And again, you could rewrite it like this if you wanted to. Let's not worry about that for now. All right, so a mixed radical basically has a number both inside and outside of the root. And again, this square root symbol is the root. If we have a number on the inside and the outside, it's a mixed radical. If the number is completely on the inside, it's called a full radical. And we can take numbers inside and outside of the square roots pretty easily, as we'll soon see. Okay. When we're multiplying and dividing radicals, you basically can say that if two variables are multiplied and they both have a house, the square root house symbol, you can combine them under the same house. Okay. Similarly, if we have a division, um, square root of a divided by square root of b, we can write it as a over b, all under the same house. So again, we can go back and forth between these two. Another way you can write this first one is square root of a times square root of b. Okay, so they all mean the same thing. And hopefully you can see, hopefully you'll see soon that this is not a very hard concept. Okay, now for adding and subtracting radicals, this is a little bit different. Um, we have to combine like terms, similar to how we would do with like x squared and x, and it'd be an x cubed, right? We're just going to collect all the terms that are similar. And again, we'll have examples of that in the practice questions, so let's get to it. So the first set of questions involve us writing this, uh, what do we call these? Full radical? Yeah, this full radical as a mixed radical. Okay, so and again, a full radical is going to have the entire number under the square root sign, something on the outside. So how can we get something on the outside? Well, let's take a gander. So the way you do that is we need to sort of decompose or factor the term under the square root sign. So why does that help us? Well, it helps us because if there is a number that we can take the square root of, we can then take it outside of the root. Chan, what are you talking about? Let me show you. So I can rewrite this as square root of 4 times 8, for example, right? And again, 4 and 8 are factors of 32. But again, the key piece is the fact that I have a square root of 4 now. And we know the answer to that, it's 2, right? So I can rewrite this as 2 times the square root of 8. Okay. And again, if you forgot from above, we can separate these outside of the house. They each get their own house, right? And then of course the square root of 4 is 2. Okay. That's how we simplify. Now we actually can simplify further. Why? Because 8 is 2 times 4. So again, we could rewrite this as 2 times square root of 4 times 2, which then we could rewrite as 2 times the square root of 4 times the square root of 2. And of course, we know this over here, or this rather, is 2. Square root of 4 is 2. So it's 2 times 2 root 2, which is just 4 root 2. Okay, very simple. We actually could have reduced the factors and multiplied this by 2 times 4 in this step, and we would have been able to get the same answer. Uh, Hopefully that made sense. I know there's really no questions here, so I'm really hoping it makes sense. Oh, that's not good. Okay, I'm gonna charge this 1 sec. Okay, in the second one, what are we gonna do? Well, in the second one, we need to do the same thing. We need to separate 360 into its factors. How are we going to do that? Well, hopefully everyone can see that 360 is 36 times 10. Okay, and 36, we know the square root of 36 is 6. So we can actually jump a bunch of steps here. Um, how's this charging going? How's this charging going? It's not going too well. Oh, this one's full battery. So let's just pretend nothing happened. Let's go back to this. Okay, so as I mentioned, we can separate this 360 into 36 times 10. Let's write that out. This is equal to 36 times 10. And of course, we know this is going to be root 36 times root 10, which is then going to be 6 root 10. Okay. Now you'll be wondering, can we reduce this anymore, this root 10? And the answer is no, because 10 is equal to 2 times 5. Oops, is equal to 2 times 5. And if we have 2 and 5 under the house, that's not, we can't remove anything. There's nothing that we can multiply itself to make 2, and there's nothing we can multiply itself to make 5. Okay, let's move on to the next question. C, root 12. So in this question, let's say we didn't know that 4 times 3 was 12, even though it's obvious that it is. Let's say we just wanted to split it up into its lowest factors. Okay, so we'll say this is, let's say it's 2 times 2 times 3, right? This over here, we have two 2's. That means we can just take them out and do root 3. Okay, and again, the reason why is because this is root 4 times root 3, right? We can say this is root 4 times root 3, and then it comes out. So again, whether you say 4 square root of 4 or the square root of 2 times 2, it does the same thing. Okay, if you ever see a number repeated under the square root sign, that means you can take it out. Does that make sense? So let's do another example. Let's say I had square root of, I don't know, let's do square root of 81. So this is obvious that it's 9, right? But again, we can rewrite this as 9 times 9, which again can be removed because there's two of them. All right. We also can write it as square root of 81, and also it's still 9. Okay. Hopefully, this is making sense so far. Okay. Notice how we can't reduce these anymore, right? Square root of 3 is nothing that's going to multiply itself to get 3. There's nothing going to multiply itself to get 2 or 5, which are the factors of 10. There's nothing that's going to multiply itself to get 2. So we can just leave it as the roots 2, root 10, and root 3. Okay. Hopefully that makes sense. So again, whenever you see a number that you know the square root of, or you have two numbers, right, we can take it out of the square root. Now, let's take a look at question 2. We're supposed to write these as entire radicals. So in the previous question, we took out numbers from inside the house. Now we're trying to put them back into the house, if that makes sense. So how do we do this? Well, we know this is 2 root 32. I just wrote the question out again, which is really unhelpful. But we also can write this as square root of 4 times the square root of 32, right? Right. 2 squared is 4. So then we can then just combine these and do whatever 4 times 32 is. Okay. And that's why I have this trusty calculator over here. 4 times 32 is equal to 128. So this is square root of 128. Okay. So this is going the opposite way. We're writing it out as a full radical. We put the entire number under the house. All right. A simplified means that we have to make it so we bring everything outside of the house as much as we can, and whatever is left inside the house, there's nothing that we can do with it. Okay. Let's try this one. 4 root 30. So again, we'll do the exact same process. We want to get that 4 under the house. So again, the way we can rewrite this is that 4 is the same thing as square root of 16, right? 4 squared is 16. Then we have root 30, and again, we have the same multiplication where if they're both multiplied, they are under the same house. And then, of course, let's get our trusty calculatrice. 16 times 30 is equal to 480. Is that 480? I can't see with this low contrast or high contrast mode. Let me try to zoom in, actually. Make it a little easier. Okay, there we go. Okay, 480. Cool. So then we write this is 480 square root, and we're done. And the final one, we want to again get this 5 inside the house. How do we do that? Well, we got to put 5 into a house first, and we know that the square root of 5 is, sorry, the square root of 25 is equal to 5. So that's another way of writing 5. We can write it square root of 25 times square root of 15. And then again, we can combine them under the same house. And once we do that, let's put this into our calculatrice. 25 times 15 gives us 375. So the answer to this is 375, all under the house. Okay, I hope that made sense. Yeah, I hope that made sense. Okay, let's move on to more questions. So these get a little more complex. So now we're adding in addition and subtraction in addition to our multiplication slash division. We didn't have any division here, actually. We have some here, so good practice, good practice. Okay, so let's take a look at the first question. First question, we have root 3 plus 4 root 3. We're supposed to simplify this, although I didn't write simplify, probably should have. And this one, these root 3s, you can't do anything with them, right? It's not like it's root 30 where we can split it up into 10 times 3 or whatever. Here, it's just 3. It's a prime number, right? So we don't have factors for that, so we can just leave them. But you'll notice that this is a root 3 here and another root 3 here. We can collect like terms. There's a 1 of them here. There's 4 of them here. We'll add them, and it's 5 root 3. So you can think of root 3 as like x in this example, okay? Think of it as like x, or x squared, right? We combine the like terms being root 3. Let's try a b. So just like last time we collected like terms, I'm going to highlight the like terms. Take a gander. We got 2 root 5s, and we got 2 root 10s. So when we do our solution, we're going to combine the like terms. We see 3 root 5s plus a root 5 is going to be 4 root 5. And 7 root 10s minus 3 root 10s is going to be 4 root 10s. Okay? Hopefully that makes sense. And again, I want to emphasize this, you can't simplify this, right? So if we tried to, 4 root 5 plus 4, and then if you tried to find the factors of this, the only one that would work is 2 and 5, right? And again, there's not 2 2s, there's not 2 5s, so there's nothing we can do here to reduce it anymore, so we can just leave it as root 10, okay? Which I will. Let's move on. We have 4 root 3 plus 2 root 9. First of all, we can't combine them. They're not like terms, right? But hopefully you can see that root 9 is just 3, right? 3 times 3 is 9. So this turns into 3, and it's just 2 times 3, which is 6. So we have 6 plus 4 root 3 is the final answer. Okay. For this kinds of questions, you don't need to convert this 6 into a root 3. That doesn't make any sense. Okay. A whole number chills by itself, and all the square roots chill by themselves, just like how we had, the root 5 and the root 10 chilling by themselves. Okay, let's move on. D, what's going on here? So D, we have a division. So the way it works is, again, you can think of this as like X, right? Actually, this is not X, this would be like Y, right? But the point I'm trying to make is you can deal with the outer numbers first and then deal with the house. What house? The square root. So again, this turns into 3. 12 divided by 4 is 3. Then we have root 27 over 7. So, sorry, root 27 over root 7. So let's go back to our thing. What thing? Our division rules. We can see over here, right? If we have a root divided by another root, we can combine them all into the same house, under the same square root sign. Okay, so I can say this is 21 over 7. Does that make sense? And this just turns into 3 root 3 because 21 divided by 7 is 3. And then we're done. So the division is pretty easy as well. Okay, just we're doing things separately. These are the whole numbers, these are the square roots. Okay. Multiplication. Let's give this a shot, shall we? So this time we're going to be distributing, this root 2 to these two other terms, and then we'll simplify. How do you multiply square roots? We already did it. When? Like over here, for example, right? Or over here, for example, we're kind of splitting them up. We can do the same thing over here. This is root 2 times 3 root 5. So again, when you have the square roots multiplied by each other, they can go under the same house. You can imagine a 1 in front of here. So again, we've got 3 times 1 is just 3. And then we have root 2 times root 5, which I'll leave like that for now. And then we have 5 root 2 times root 3. Okay, so root 2 is added on over here. Okay, and the root 2 is obviously added on over here. So again, this is our distributive property. At this step, hopefully you can see what to do. We have two square roots. We have two square roots, right? So we can combine them under the same house. This is 2 root 2 times 5 plus 5 root 2 times 3. And this just turns into 3 root 10 plus 5 root 6. Okay. So again, when you have multiplication of square roots, you can combine them under the same roof. We done. And the final question for this fantastic Friday is this FOIL question. So this one we need to completely FOIL. So we're going to start with root 5 times root 5. I'm just going to write it all out first, and we'll deal with what this actually means. Then we have root 5 times 1, so plus root 5. Then we have minus 3 times root 5, so minus 3 root 5. And then we have minus 3 times minus 1, which is minus 3. Okay, how the heck do we do this, you ask? Well, luckily we have a whole bunch of root 5s, right? So we can just combine them. However, notice that this is root 5 times root 5. What's that equal to? Multiplied roots can be under the same house. Okay, so if you actually take a look at this, this just turns into 5, right? 5 times 5 is 25. What's the square root of 25? It's 5. So this is 5 plus root 5 minus 3 root 5 minus 3. Now, I probably should have combined the other two terms because they have the same common like term, right? So now what I need to do is just add them together. So I've got 5. Oh, I guess I've got the whole numbers as like terms as well, right? So I've got 5 minus 3. This will be 2. Then I got root 5 minus 3 root 5. There's one of them here. I subtract 3. We have 2 root 5 left. And we are done. That didn't take too long. So hopefully everyone is feeling relatively good about that. And if you're not, please do let me know. The homework is posted. Hopefully everyone has a great weekend, and I will talk to you soon. How do I stop recording? Um, Stop recording. Goodbye.